All right, everyone. Welcome today to DBA Fundamentals presentations of all kinds. Today, we're talking about dividing and conquering, all about partitioning with the Stuart Moore. Today is July 25th, 2023. So, yay fun to us. Today is, well, in the upper right-hand corner of the screen, hopefully you all will see the three leaders of the DBA Fundamentals group. Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. If you need to get hold of us for any reason, the easiest way is to get a hold of us on the Twitter handle right now. Quick and easy way to get hold of any of us. Below that, you will see several of our social media platforms. First off is obviously Meetup, where you can actually get hold of us, actually see all of our presentations that we have upcoming. Hopefully it's one of the ways you've found us and signed up for our little presentation today. Below that is our website, dbafund.org. I say .org, but it's actually been brought to my attention that the .org doesn't function anymore. So if you go to dbafund.com, I know that one works as well. I'll actually make a change to the slide, but I know the .com works for sure. Yeah, so on our website, you can actually see all of our past presentations as well as our upcoming presentations. So be sure to look out there for that to see all of the goodness. Below that, you'll actually see our video channel, dbafuntube.com, where we have all of our past presentations. Be sure to look to actually like and subscribe to our dbafuntube.com, just so we can just so you can actually see the presentations whenever they're actually available to you, which is usually pretty quickly. We have that out there. Also below that is our Twitter handle, our Slack channel, and our LinkedIn group. Make sure to follow us on all of the social medias that you can, because there's a lot of stuff happening in all of the groups. As I said earlier, today's session is being recorded and usually available within 1 to 2 days. Be sure to check us out on our channel, dbafuntube.com. Below that, I like to focus on some of their upcoming conferences. This year, on September 16th, 2023, is one of the ones that I'm actually looking forward to, Data Mosh Pit. It's in Germany, so it should be a great time. That one looks really, really cool, because it's where data meets metal. You know, it sounds fun. We'll see what's going to happen with that one. On the right, you'll see one of the conferences that I'm actually a part of, the Future Data Driven Summit 2023. Be sure to actually link to actually register for that one, because it is coming up really soon. It's September 27th. I want to be part of that one because there is, I think, 5 tracks to that this year. Previous years have been 3 or 4. I think there's 5 tracks this year, so it should be great. Below that is Microsoft Ignite in November, so there'll be lots of great presentations there as well, since it's coming straight from Microsoft. Also, this year, be sure to, if you've not already, be sure to sign up for Past Summit in November 14th through 17th. Today, I actually just received today the little code, so you can get $150 off your registration pass or a 3-day pass to Summit. So be sure to do that soon. Today, I believe the price is $15.95, but if you wait till July 27th, which is in 2 days, it will actually go up to $17.95. You get $150 off if you use our code anyway. Be sure to turn off your camera if you have it on, and also please mute yourself so we can all focus on Stuart. And if you have any questions, be sure to type it into the chat. And so with that, we go over to Stuart. There's his little bio, and I'm sure he has a much better one. But for that, we go over to Stuart.
I've certainly got one that's a little bit more up to date. But yeah, Data Mosh Pit should be quite good. I'm actually wearing, I think it's the same guy. He did the T-shirts for the PowerShell conference about 3 years ago. So he's got an eye on for those things. And Not sure how international the audience are, but if there's any UK residents on, also to announce Data Relay. We're back in October for the week, the first week, full week in October, traveling around the country. We're doing, I'm trying to remember now, Bletchley Park. We've got the National Museum of Computing for the day. Then we're down in Reading, Bristol, Birmingham, and Manchester for the usual 5 days of conference fun, going to different venues. So we'll be announcing speakers starting this week. Hey, that's enough promotion. Now on to partitioning. Right, hi, I'm Stuart Moore. If you read the other bio quite quickly, it's not changed too much. Started with SQL Server 25 years ago, with SQL Server 7 just missing 6.5. I was a data platform MVP.
Are you sharing your screen?
Oh, sorry, I thought you'd reshared it. Sorry, that's my fault.
There we go.
So you can see the bio now, right? Okay.
Yes.
I'm used to other platforms where people take it over. Sorry. Anyway, yeah. So was a data platform MVP for 5 years, but life got in the way, so I've not renewed. And I'm just doing more and more with Azure and scripting and automation these days, and less time purely throwing data around. As you'll notice, I like plain uncluttered slide decks. My contact details are there. You can email me. There's a GitHub where all my presentations go, and I'm on Twitter or X or whatever we're calling it today. So if you want to ask any questions post session, feel free to get in touch. So those second demo scripts we uploaded afterwards gives me a chance to fix any errors as we go through them. So, partitioning, what is it? It's a way to carve up data within a single table. We're all sort of used to carving up data, into vertical slots. So you go to third normal form. So you've got tables, data goes across tables. You can join them back together. The problem comes when you've got a table that's approaching a couple of million or a billion rows, and it's just a huge blob to manage and sort out. So it'd be nice if there was some way to take that massive table and cut it down to smaller chunks, but not have to think of it as separate chunks. Otherwise you end up doing unions all the time. So when you do that, what you really want to do is you want to have strong boundaries. So when you split the table, you can specify the boundaries and they will be enforced. So if you say, oh, I want any data like this in the first partition, the second partition, the third partition, it will go there and it will stay there. You also want some form of indexing that understands how this data is divided. As we all know, clustered indexes and other indexes are great pieces of tools, but generally they're designed to work across one large table, not across lots of bits of table. And also, it'd be nice to have to split a single table across multiple file groups. If you've got one of these massive tables, it's a big chunk of storage you've got to manage. It'd be nice if, for various reasons, if you can split that big table up into, say, 5 or 6 different pieces of storage, and then you can mount them on different disks and different file groups. You can treat the backups differently as them as well. Partitioning lets you do all of that. And that's the short version. As we go through, you'll see this is more in depth, exactly what you can do with it. Anytime you do a demo, you talk about something, the first thing people ask, is this a latest version thing or an enterprise feature? No, it's not. Introduced enterprise feature in SQL Server 2005. It's now available in all editions. So, if you've got your standard SQL Server license, you now have partitioning available using SQL Server 26 SP1. It's also available in Azure SQL database and Azure SQL managed instances. In fact, it's how under the hood sometimes they will manage their own data. The only bit that's not really applicable to what I'm going to show you in this session and the demos between your own SQL Server box and the Azure SQL stuff is in Azure SQL stuff, you don't have multiple file groups. Everything's in the one file group. That's the only difference, because Microsoft don't give you access to this at that level. So there's a good chance you probably already have access to it. So there's no cost to implement it, but that no cost usually assumes that DBA time is free. As we go through, you'll get the idea that it's quite important to plan ahead a long way when you're setting up partitioning in the first place. You can alter it. It's not fun. If it goes wrong, it goes really wrong. So it's not something you can just turn on. You've got to think about your data, the life cycle of the data, and potentially think about that life cycle for a number of years ahead, not just getting you through the current issue. Is it a performance boost? People say it is. It can do, depending on your workload. There are some specific queries that will benefit from partition elimination, which will speed them up and cause them to use less resources. I'll show a couple in the demos, but it's not a guaranteed performance fix. What I find it's really useful for is managing these very large tables. You know, you can split them to smaller files, so it's easier to manage small files than one huge, massive file. You can move the partitions onto different storage. So for a lot of these examples, date is the easiest way to think about data, because everyone has data that's arranged by date somewhere in their system usually. You can do it lots of other ways. So I'm going to talk about date a lot. My demos use date because it's something very easy to set up and something very easy for you to understand. So for instance, if you're partitioning on date and you've got maybe, you know, data that's 5 years old, 4 years old, 3-year-old, and the current data, you may want to store that data on different performance disks for cost reasons. So stuff that's 5 years old, it's nice to have, but it can sit on old, slow spinning disks. The stuff you're actually working on now, you want on SSD or flash memory. It's the same table, but the storage is split across the different partitions. So that can be very useful if you can't afford huge amounts of fast disk. You can switch partitions in and out with a metadata change. We'll show you this in the demos, but this allows for near instantaneous loads of massive amounts of data into a table. As well as switch partitions, you can use that to drop a load of data that you don't want there. So again, if you're partitioning by year and your company's policy is that anything over 5 years needs to be removed, that's fine. You can just chunk it out. It goes from the table. It's a metadata operation. There's no locking, no blocking. The users will only notice when they try and query the data. And you can also improve your backup speed as well. We cover slightly further on another slide. So how does a partition table work? As far as you and your developers, for most of the time, need to think about it, it is just a table. There are things under the hood, but you can just query it. Usually it's a table that's so big that if you do a select star from, you'll be set there for hours. But it is just a table at the end of it. The two bits you need to define a partition table as opposed to a normal table are a partition function and a partition schema. The partition function defines how you split your data into the right partitions. Basically, you give SQL Server a list of values, and it knows to put anything less than the first value into its partition, anything that's creating that value into the second, the next value after the third, next value after the fourth. Again, there'll be examples which will make it more obvious when we get to the demos. There are two types of partition function: left aligned or right aligned. And all that does is define which side of the boundary we put. So if it's a left, the right boundaries include right up to the boundary. So you can see the right level, that would be values splitting at the 0, 10, and 20. So 9.999999 stays in the first partition. With a left boundary, the next boundary value is in the partition on the left, and anything greater than that value is in the right. Again, this is great with dates. So if I started a partition on the first 2011 00:00:00, it would run, and it was right aligned, it would go all the way up to 31-12-2011-23:59:59. So everything that we would think of as 2011 is in one partition. and that's it. You have to look at your own data and work out which way you want to do it. Partition functions are not easy to alter. You can do it, but it's a little bit of merge and split to try and get things apart. You'll get one default partition to the left of your first boundary, even if it's 0, just because SQL Server wants somewhere to put data elsewhere. Unless you put a constraint in your databases, you're never going to go below that boundary. Because they're not always the easiest things to alter, think about the life cycle of your data in the partitioning. Create more partitions for the future. So if you're setting up partitions for monthly data, so you wanted to put, May 2023, June 2023, July 2023 data all in separate partitions, think about doing that for another 5 years. You can create them programmatically. You don't have to do this. I've got an example of creating them programmatically in the demo. Because when you attach storage to these via the schema, which we're going to look at next, you can assign a tiny file. It just needs something because you're not going to put data in there. It does mean you can just keep going forward, and there's no performance hit on the number of partitions you have. So that's what I mean about thinking of it further ahead. If you're going to do it, create it for the foreseeable future, and that should be great. A partition function can be applied to more than one table. So you can use the same partition function on HR and finance data, which will keep them in the same, in sync for dropping partitions as you go along. You can partition on any data type where SQL Server works out how to, this is the same or it's greater than that, except for the blob ones and CLR data and CLR defined data types. You can use computed columns if you want, but the value must be persisted. Once a value has been put into a partition, SQL Server will not move it if it changes the value. So the computed column needs to stay as it is. It will stop you putting the data in if it's not persisted. So the next bit is the partition schema. So this tells SQL Server when you set up your partitions, you set up the function to say how to split stuff into partitions. The schema then tells it where to put these partitions. There's two main options. One, you can map everything into one file group. That's easier to set up. It's harder to move partitions to slower storage for archiving. And you've got less to say about where things sit. But it's nice and easy to set up, and you still get a lot of the other capabilities we're going to look into. You can map each partition to its own file group. It's a bit harder to set up. You need to create groups for each partition. But again, you could automate that quite quickly to generate the statements for you. And you've got greater flexibility on where you want to store your data. Because each file group can be put on its own disk or moved around as and how you want it and sized accordingly. So like I say, you can create schemas to a file group that's 1 meg in size. So it just wants to be able to put a table definition there to start with. So talk about planning ahead. People always ask, how many partitions can you have? When it first came out, it was 1,000 partitions. 2008 and 2008 you had a stored procedure to increase that to 15,000. From 2012 onwards, 15,000 partitions are enabled by default. And for example, that would give you a daily partition for 41 years, or an hourly partition for the next 1.7 years. So don't worry about the constraints of partitioning going forwards. It's got enough to cope with whatever you want to do. But I've seen people get stuck when they've hit the end of their 12 months and have to work out what to do next. This is one of the real power moves of partitioning. You can switch the data from a table into a partition as long as it matches up with data types and constraints, and it's just a metadata change. The SQL Server does it under the hood using its own system tables, and indexes, queries, the lot just instantly fall over to use the new data. It's a bit hidden under the hood how it does it, but it does it absolutely fine. So this means if you've got a big overnight load you load into your data warehouse each morning, you can sit and run it on data that users aren't looking at, and the next one just switch it in to the data warehouse ready for them. If you're doing overnight loading, rather than having it running actually on the data warehouse, locking potential blocking issues, using up CPU that users would rather be using, and do things like that. You can get backup improvements because with the different file groups, you know which ones contain old data that's not changing. So I've just seen Kirby's question. Oh, sorry, yes, scheme. Where I got schema from? I had it in the brain all day. Yeah, and smaller partitions, doing it by year, yeah, you've still got a lot of data in there. But yeah, it's whatever works for you, because a lot of it's going to depend on how you want to delete your data or load it. So I didn't see that one coming in. Thanks for that, Kirby. So by splitting the partition into file groups, you can then choose where to put these file groups. And some of them, you know, will not be updated. So the partition with your 2012 data is probably just sat there doing nothing. So you don't need to back it up every night. You've got to back up its static data. You can store it somewhere else. So that can reduce the overhead there. And now the fun bit, demos. Has anyone, just before I go into that, has anyone else got any questions?
No questions.
Just going to check out these in transparent mode. There. Great. And let's see. Can everyone see Management Studio now?
Yes, we see it.
That's brilliant. Sorry, when I switched screens on the Mac, Teams stopped showing the red outline, so it's always a bit tricky. Right, so I'm just running this on SQL Server 2019 Developer Edition on an Azure VM. So I'll give you the scripts you can play along if you want to. So first of all, just going to create a standard database. So I forgot to grab the script before I built the database for testing. Just picked up the sizes. Bear with me. There we go. Just use the database and we'll create a numbers table. Just in case you've not met it, these are a great way of generating large amounts of data. Just create a table full of numbers and you can use to build other tables. There we go. So just create a couple of tables, a flat table, and a clustered index, sorry, a clustered table. Let's get rid of that. I just need that later on in the session. So now we actually get to the meat of it. So this is a partition function. I'm creating one here on a date time column. There's a range right for the following values. So 2014 to 2017, so 2014 to the very end of 2016, 2017 to the very end of 2019, so sort of 3-year splits. Create that. And this table, I'm just creating it as one big partition, as one, yeah, to one file group primary. And then here's actually creating the partition table. As you can see, it looks exactly the same as a normal table create statement, except here it has created on partition schema. That's not going to work then because I've got the wrong name. That's where I've got confused. Sorry, I've named my partition schemas and I've just coded that across. Sorry. I was wondering where I got it confused. So that has now created us a partition table. Just to show you what it's like creating another one, here's one that we spread across a number of file groups. So I got myself some file groups here, going through the same splits again. Each one's going to its own file group at the end. We create another partition function. And here's the example of creating a lot of them at once. So this is creating one partition per day between 2023 and 2026. So you can just run this, it'll print out the function, and you could drop it into execute SQL if you just wanted SQL to run it for you. Mike, I'm going to upload the demo script and the PowerPoint to my GitHub once I've finished. There'll be a link to the GitHub on the last slide. So just take a note of that. It should be up there in the next hour or so. There we go. So same thing again, create a partition schema and create the table. What I'm just going to do is quickly insert a lot of rows into all 4 tables. It's always slower when you've got an audience.
It's everyone's favorite kind of demo, waiting for the
That's it, yeah.
demo to finish.
It shows it's live.
That's right. So while we're waiting, I know Mike asked, where can we get a copy of this script? I'm sure it's available somewhere.
Yeah, I'm going to upload it onto my GitHub at the end of the session.
Perfect.
Which is in, it's on the last slide of the PowerPoint. I'll cut and paste it into the chat so everyone can find it easier.
Awesome. All good.
Yeah. Oh, apologies, this was much faster. Yeah, I've just got that turned on so I can see for the next couple, we're actually going to want to look at the execution plans. So it's not been this slow before. It's the same box I've been using. There we go. Right.
There we go.
So just so you're starting to complain anything about touching something. Right. So let's just look at single row query performance across the 4 of them. There we go. As you'd expect, the heap is slow because it's doing a table scan, and all the others are doing a clustered seek, which is nice and fast. So about if we stick the query, and this is bounded just to make sure it sits within one partition. So this is a bit of a cheat query. There you go. So we still see that the heap is the biggest cost. And then it drops off. So there is a slight performance improvement for the 2 partition tables over the clustered index. And that is because, there we go. If you now look at the properties on the index seek, you will see there's 2 new values populated in there. You've got actual partition count, which tells you how many partitions in the partition table were accessed. In this case, because I've made it fit into one partition, you're just accessing one of them. And here it tells you which partition has been accessed. I have no idea about the video. I think, but I expect it's being recorded. So that's what you can see. You can see 1 and 3, and that's giving it a slight boost because it knows to ignore the other partitions. Let me just do a quick one across multiple partitions. As you expect, it's still neck and neck between the two at the bottom because there's no real load on this box on the disks to make a big difference. But if we look now at the properties, you can see it tells it's access 2 partitions, and the partitions are 3 and 4. If it's a contiguous set of these, it will just ignore the numbers between and put these 2 dots. So if you see 3-5, did everyone lose sound with me? Or is it just Thomas?
I still hear you.
Okay, that's good. Just making sure something had on my end. Yeah, Mike's got it as well. So that shows you that you can occasionally get a small performance boost from partitioning, but it's not the main reason for doing it. Now, this is one I do like. I put those in the wrong order. Right, so create a table called holding years, and I'm creating it on the file group that I know the partition is on. But that I want to extend out. But those need moving, so I will move those before I put them up. Confuse people. So currently, holding table is empty. Just in case things get slow. So what I'm now going to do is issue an auto table statement, which is going to switch out partition 4 from our file partition table into holding table. It's done it. And just like that, I've moved over X'd out 1.5 million rows from the partition to my holding table. That's how quick the metadata switches. And if you check the partition table, you've got to remember it's actually switched that out. That data no longer exists within the partition table. I'll just show you how fast you can pull the data out. You can do the opposite thing. We can alter the table to put this data back into the partition. Now this will explicitly fail because I'm not setting it up, but it's just to show you the error you get. It complains about the values. People get confused by this. People get confused by this because you just pull the data out from the partition. It must fit within the partition. Yes, the data's not changed. It will still fit in the partition. However, SQL Server, like its DBAs, is quite paranoid. It doesn't trust your data. It actually wants there to be a constraint to prove to itself that the data fits. So if you're going to be switching stuff in and out of tables, the table must have a constraint that ensures the data will fit back in the partition. Yeah, SQL Server doesn't care if the data is good or not. It just wants to see that constraint and know that it's enforced. If I do this now, it goes straight in without complaining. I've seen a lot of people scratching their heads around this when they know their data fits, and it just doesn't go. Just to prove. There you go, 1.5 million back in the partition table and nothing in my holding table. So that's great, but I've just shown you that I can take the same data out and put the same data back. So now an example of where you can take data out and load in brand new data if you need it. So we create an incoming table. You'll notice I've actually put the constraint into the table create statement this time. Yeah. So I'm just going to create some new data into the incoming table. Bingo. Switch out the file partition table to the holding table. We've got data in the holding table. Yeah, so that's switched out absolutely fine. So this is like taking a backup before you do anything on your database. What I'm now going to do is load my incoming table. Brilliant. I've reset the numbers in here. And that's starting from 1 rather than where it should have been, which is a couple of million. Now, the benefit of this against the data load is also we can go, oops, we got the data wrong. Someone spots a problem. So we've kept the holding table. We do that. And we switch them back over. There you go, which is what you expect. See the bigger numbers rather than the millions that were coming through. So it just shows this a nice way to load data and have a backup plan as well once you've loaded it. And that's, that's a really big use of it. I'm just going to show a couple of examples of using the sort of built-in $partition file. You can actually look at how your partition function would work and use that to query it. So here, I can ask for the minimum maximum date. So just some background noise. I thought Kevin was about to ask a question. So just to set the minimum maximum date from the file partition table, where $partition dot file partition function. That's our partition function. And where a value of date would give it a value of 0. So this is what is in our 0 partition. Partition is a number from 0 upwards. So if I do this, there's nothing in there because we didn't load any data below 2011. There you go. So this actually, you quickly check your partition function. Another option you have is you use your straight select. This will tell you into which partition data on that value would go. So that's a nice way of checking your partition function is working the way you think it's going to work. If you're working with, say, a computed value or one you've combined yourself, you can test it out without having to load lots of data. And you can use it to do things like a selective count per partition. Just by using this function. So it gives you a little bit more insight into what's happening within the partition table if you wanted to, without trying to work it backwards. It's always good for a little bit of a sanity check. Yeah. And that is the demos. Let's get back to here. So partitions is a great thing when they're needed. The trick is knowing when they're really needed versus when an easier solution will produce the same results. Performance indexing is probably a much better idea. And like I said, planning things ahead. As I'm sure that Kirby will back me up on, you do have to think ahead with these. Or you end up with not enough or too big partitions or too small partitions. So think what you actually want to do. I do like them for using data loads. Nice just to be able to switch stuff in and switch out. And as well, good for compliance. You want to remove data that's 3 years old, you just dump the partition, and it's gone. Which is a nice thing to do. That ended the presentation and the demos. Anyone have any questions or thoughts?
I have a question. I hope you can hear me.
Yes, I can hear you, yes.
What are some considerations for handling Singleton updates against a row in a read-only partition? So I'm thinking of a scenario where, some of the data that I work with is, it's pretty stale, but every once in a while, somebody might decide, oh, I want to update a record that's 3 years old or 5 years old. Any thoughts about that?
Yes, that's where you need to have a think about your long-term plan with these. Because if you've got if you know that people are going to make updates on, a particular financial year date, then you could always enable, write access at that point. If they could be ad hoc at any time, do you really want to make that partition read-only?
Okay.
A lot of times I've used partitioning. I know the data is either only managed by data loads overnight, or is not touched because we'll have finalized things at the end of the month. So that month's now set in stone.
And then just go additive from there on.
Yes, that's it. Yeah. So I'd ideally be looking at my last partition is currently live and working OLTP. Anything further back has been sort of archived off, as it were.
Okay, that makes sense. It's kind of
yeah. That's.
I'm sorry. Go ahead.
Yeah, it sort of depends on what you're doing. It's again financial data in the UK. Is we tend to run August. Well, sorry, universities run August to August. So at the end of August, once it's signed off in August, that's it. It's locked down, and we start the new year. So, yeah, again, it's knowing the business process and how best to do it. To be honest, apart from the backup things, there's no real overhead in leaving them live. You just wouldn't necessarily have to be able to guarantee the backup from 2 weeks ago is still valid.
Right. Have you ever used like highly performant storage, like low read latency, super low write latency for the more active and or current partitions?
Yes, that's it. Because you put them in a file group, you can move the file group around like any other SQL Server file group.
Okay.
So you have a file group with the first stuff.
I've been considering whether or not to even consider ephemeral storage for that type of thing with HA. Thank you.
Yeah, as long as it stays available even when it fails across, yeah, it shouldn't be a problem. As long as it supports SQL Server supported storage, this will support it. In the day, they're just very fancy tables.
Okay. Thank you, Stuart. And also, thank you very much for your advanced restores with DBA tools. I really appreciate that.
Oh, yeah, yes. That was a long time ago I wrote all that. Yeah. I've not looked at it for a few years. No screens, I'm assuming it's still working.
All right. Do we have any more fun questions? You can come off mute. We don't mind. We don't bite too hard. Well, I don't some days. Or if you feel like just put it into the chat, I can ask as well. All good. Either way, whichever makes you feel more comfortable. While everyone is thinking about the questions they want to ask, if they have any, I do want to remind you that coming up on August 22nd is our next presentation. It is about handling Azure SQL auditing with ease with Josephine Bush. And then September 12th, we have Rob Volk doing 10-year unruly data with constraints. Please be sure to join us for either of those or both or all. It's all good. Yeah, so I want to remind you of that. So yeah, if you have any more questions, please be sure to either come off mute or put them into the chat window. We'll be here for the next few minutes until everyone is happy, has all your questions asked and answered. As always, though, Stuart, thank you for such a great job going through partition.
Yeah, that's no problems. Yeah, yeah, glad to help out. Yeah. Hope everyone else enjoys their evening. Sorry, your afternoon. I forget it's evening now. I'm back to sit on the sofa and film for you.
Morning, it's all good.
Yeah. Yeah.
I know we have people all around the world, so it's all good. All right, it looks like no one else has any further questions. So with that, I will be ending the session here in just a minute. So thank you very much, Stuart, again. This has been fun.
You're welcome. Thank you very much for having me. Cheers. Take care.
Thanks, y'all.